So let's take a look and see what the OSI layer looks like in an actual demo, starting with the physical layer. This is talking about the cables, the NICs, the routers, the switches, any physical devices that we're talking about. Then we go into layer 2, which is going to be the data layer. And the primary focus here are going to be MAC addresses. These are the unique identifiers that every machine that can talk on the internet will have. It's also going to tell the network how to know what the source and destination machine are. Next, we have layer 3, which is going to be your networking layer. This is going to be where IP addresses are first introduced. We also are going to actually start dealing with routing now. And there's going to be a protocol called ICMP that also runs at this level. Ping is something you're probably familiar with, and that runs on ICMP, which is a layer 3 network connectivity check. In this demo, I'm typing in the IP address of my server on the top right, and I'm running a ping, which again runs on ICMP, and we can actually see the traffic. So first that little mail goes down to the switch. The switch then knows where to route it based on the IP address, so the server receives it. The server will then reply back to the switch, and then the switch will send it back to the original source. Next, we'll move into the transport layer. There are two main protocols used here, which we talked about in our previous deep dive. That's going to be TCP and UDP. For this example, whether I send an HTTP request, which is going to use TCP. Just like before, we see the client sending a request to the server. However, the difference here is if we look on the side, we can see that the type is listed as TCP, not ICMP, which the ping was using. This is important to remember because TCP works on layer 4, ICMP works on layer 3. Layer 5 and 6, the session and presentation layer, you won't really see in the troubleshooting perspective. Just know that they're handled by the operating system and what their functions are. The last layer, layer 7, is it referring to the application itself, like Google Chrome, Discord, or Outlook? Instead, it is the interface that provides network services to those applications. And that's what allow for things like web pages or chats to pop up. Now that our application is running, let's take a look at what this looks like from a full OSI model. We started with layer 1, which was going out a physical port. Then we moved to layer 2, which are our MAC address. In this one, it's the server sending a client a packet. So we see the source as the server MAC address and the destination as the client MAC address. We then move up to layer 3, which are IP addresses. So the source will be the server IP and the destination will be the client IP. We can see that inside of our IP configs on the left and right side. We then move into layer 4, our transport layer, where we're choosing a protocol. Remember, this will be TCP or UDP. In this scenario, we use TCP because we did HTTP request, and that's what HTTP runs on. We then get to the layer 7 application layer, which in this case is HTTP, and that's the layer 7 protocol that's being used for the application itself. A thing to keep in mind here are that we talked about two different protocols, but they work at different layers. The TCP and UDP worked at layer 4, whereas HTTP, SSH, RDP, those application protocols work at layer 7. I hope this helps. If you want live demo or have any more questions, just leave it in the comment and let me know.